Modern AI crawlers and data harvesters are treating library-integrated systems like Koha as gold mines. These bots ignore standard protocols like robots.txt, operating as a relentless swarm that opens thousands of connections to extract catalog data. Every time a bot requests a secure page, the server has to negotiate a TLS handshake. TLS is a cryptographic protocol that provides end-to-end security over computer networks. The asymmetric math required for these handshakes quickly exhausts the server's CPU cycles. While the server's processor is maxed out dealing with automated requests, legitimate human patrons are left staring at loading spinners. The library suffers severe latency and an effective denial of service. To protect the catalog, we deploy a Web Application Firewall, or WAF, at the network edge. A WAF is a security system that monitors, intercepts, and scrubs HTTP traffic between a web application and the internet, acting as a bouncer for your network. By terminating the secure connections and doing the heavy cryptographic math at the edge, the backend Koha server is relieved of the processing burden. It regains the power needed to serve actual human patrons without delay. Let's compare the traditional approach of using legacy firewalls like mod security against modern containerized security solutions. Mod security relies on static databases and regular expressions to identify threats. Modern botnets bypass these static rules effortlessly by constantly rotating their user agent headers and obfuscating their payloads. We will now use SafeLine, an open-source firewall that utilizes semantic analysis. Semantic analysis is a detection method that parses incoming code contextually to understand its actual intent, rather than simply matching it against a list of known bad strings. SafeLine intercepts the outbound response and dynamically encrypts the HTML and JavaScript. It then issues an invisible proof-of-work challenge. A legitimate browser solves this in milliseconds, but low-resource scrapers fail and get dropped instantly. This chart compares the effectiveness of Mod Security Level 1 against SafeLine. By evaluating the intent of the traffic, SafeLine achieves a 76% detection rate with near zero false positives. Step 1 is to prepare the edge server. You need a dedicated machine running Ubuntu Linux, and you must have root or sudo privileges. Check your system memory before beginning. Open your terminal and type free-h to view your available RAM. SafeLine's semantic analysis engine requires a minimum of 2 to 4 gigabytes of memory to process payloads efficiently. Run in standard update commands on your Ubuntu system. This ensures all local package repositories, security patches, and necessary compilation dependencies are current. Positioning the edge server with sufficient resources and updated packages prevents the firewall itself from lagging or crashing during a high-volume attack. SafeLine deploys via Docker to keep its components isolated from your host operating system. Download and execute the official Docker installation script on your Ubuntu machine. Next, run this automated bash script provided by Tech. It automatically pulls the Docker images, configures the database, and deploys the application stack. The container pulling process will take several minutes, depending on your network speed. Wait patiently and do not close or interrupt the terminal session. When the installation finishes, the script generates your initial username and a one-time admin password right in the terminal output. Copy this credential immediately. If you clear your terminal without saving it, you will not be able to log in to the administration dashboard.
Open a web browser and navigate to your edge server's public IP address on port 9443. Your browser will show a security warning because the initial SSL certificate is self-signed. Bypass this warning and log in using the admin credentials you copied from the terminal. Once inside the dashboard, navigate to the Add Application section. We need to define the reverse proxy rules that will route public traffic. Input your public library domain name so the proxy only responds to valid host headers. Set the listening port to HTTPS on port 443. Next, enter the private LAN IP address and port 80 of your backend Koha server into the upstream server configuration. Save the configuration. To verify the connection is working, open a new browser tab and navigate to your public domain. Return to the SafeLine dashboard and check the traffic metrics. You will see incoming requests successfully routing through the proxy interface. Click on the Attacks tab. This module logs intercepted malicious traffic, showing the exact payloads and dropping SQL injection attempts before they reach the database. External traffic must now pass the edge firewall's interrogation. The backend Koha server processes only clean, verified requests over the isolated local network. The Koha server is shielded from direct internet exposure. The edge server absorbs the cryptographic workload,
keeping CPU usage and database connection pools stable. Between the two solutions analyzed, SafeLine provides the superior defense against modern application layer exhaustion attacks. The semantic detection engine and automated container environment eliminate the need to manually write complex regular expressions or constantly update block lists. There is one operational side effect. Because the proxy intercepts the traffic, your Koha server's internal access logs will record the WAF's internal IP address rather than the real public IP of your patrons. To resolve this, install and configure the mod RPAF module on your backend Apache server. This transparently rewrites the remote IP variables, restoring true client visibility to your analytics and completing your secure library architecture.